we were looking at what we do to the equilibrium constant if we do something to the equation. And so here's an example of this. Consider the following chemical equation and equilibrium constant at 25 degrees Celsius. Here we've got 2COF2 in equilibrium with CO2 plus CF4, and K is equal to 2.2 times 10 to the 6th. First question, does this equilibrium constant tell us that the products are favored or the reactants? The products. K is a large number, 2.2 million, much larger than 1, which tells us there's a lot more products than reactants at equilibrium. So now it says calculate the equilibrium constant for the following reaction at 25 degrees Celsius. So we need to look at this carefully. What's different? It's like Sesame Street. It's flipped and multiplied by 2. Yeah, we have to invert it and square it. So here we've got technology issues. Here we have COF2 as a reactant. Here we have it as the product. The coefficient here is 4. The coefficient here is 2. These two guys are the same, but here they're reactants, here they're products, so this is all multiplied by 2. You might say, well, why don't we just divide all the coefficients by 2? But the question wants this, and so we have to do that. So then what we have to do is we have to remember these 3 situations. If you reverse the equation, you invert the equilibrium constant. And we did the math to show why that's true. If you multiply the coefficients by a factor, you raise the equilibrium constant to the same factor. So in this example, we multiplied all the coefficients by 2. So that means we need to square the equilibrium constant. And if you add 2 equations, you can multiply the constants. It's not going to let me draw. So what we need is 1 over K, and we need it to be squared. So we're going to take that original equilibrium constant into the 6th, and we're going to square it. And you could write this down in ways that might look a little different. This is just how I chose to do it. On my calculator, doing 2.2 EE6, I'm pressing the invert button and then the square button, and I'm getting, we'll stay with 2 sig figs, 2.1 times 10 to the minus 13 is the equilibrium constant for this reaction. Does that favor the reactants or the products? Reactants. That favors the reactants, right? There's a lot of reactant and very little product, which makes sense because we're not really changing anything, are we? We're just writing the equation backwards. Any questions?